transmitter and the receiver. That word is back this way.
Why?
Yeah, he's also working with a similar project.
Sure, yeah.
So he want to ask some questions from.
Yeah, of course.
So, what did you guys use to like code the robot?
A lot of it was using ROS. So that's the operating system that we had basically used. And we actually ran scripts off of like certain format, for example, that we're able to run Harvest off of. So what we had to do first was to basically flash ROS over the SD card and install the SD card onto the Raspberry Pi. And then from there we were able to code using ROS basically.
Oh,
Yeah.
what is ROS?
ROS, oh, sorry, I should have mentioned. Basically like an operating system. So it's like a robotics operating system, what it's called. So what it does is basically using any type of like Raspberry Pi. Think of it like a Mac OS, you think of like iOS, any type of operating system. But it works similar, it'll basically work with all the scripts and functions. So Arvis, for example, would have a specific function or script that has to be launched in order for it to get to work. And a lot of it was actually kind of a hassle, but a lot of it was basically getting the Raspberry Pi to go through connecting with ROS and for it to be like flashing on there properly. That took a long time for us to figure that out. And then learning certain scripts from it were difficult. And then we basically had ROS core launched within our, we basically had ROS core launched, and then from there we were able to go through and have Arvis launch as well, and then able to SSH into the Raspberry Pi itself, and use to basically control it from the laptop.
And these. Sorry.
Did you guys build it yourself?
No, so a lot of, so it can kind of have those packages as an example. We didn't have to reinstall different amount of things. So the lighter itself, for example, we had to flip in order to get it to work properly. We also had to adjust a few things like installing the camera itself. We had to reinstall the serial motors on the bottom more efficient.
Yeah, we were working with the mechatronics lab here at the university, so they had a lot of the components motors, right?
Yeah.
So we were going to get them.
What's the thing on top?
That's the LiDAR system. When it does, it shoots out laser. That charger just like the back end, and from there it's able to see, based on the time it takes for the laser to come back, it's able to create a map of like a 2D representation of where it's
So basically, it comes back, and it's like, oh, that took 2 seconds, it'll be this far away.
And if it detects something that was there but suddenly isn't, you can really see him walking, the steps he's taking as he goes through. It's able to pick up on if something's a moving object or something a stationary object, based on if it's changes location.
Based on the movement.
Correct, yeah.
So what is the difference between the other guys using the autonomous thing and the machine learning?
It depends. I'm not sure which other group it was.
Okay.
Yeah, you haven't been able to walk around and see it.
Yeah,
Yeah.
we're not sure who else here.
They are using like a sensor or something that detect colors and they're moving around.
Oh, that's going to be a bit different than us.
Yeah.
Ours is going to be using LiDAR mainly, and then basically from there going through and having Arvis connect to the Raspberry Pi, which controls the Arduino, and which goes to the motors, and this kind of works in a very like step by step kind of process. It gets it to move in.
So for example, let's say you can decide from A to B to move,
Right.
and it's gonna do it for
Right. Yeah.
Okay.
This next one kind of shows A to B. Oh, sorry.
And if there's any obstacle in the between, it's gonna adjust and move to the location.
Correct. Yeah. So you see here, Patrick, who actually was controlling the robot, had to move it around a bit just for it to format and understand where it is in that map. This was previously mapped in the last slide. You can see we collect an arrow, pinpoint it, and it says to travel here, and to face in that direction. So you'll see it travels to that location, just based on what it knows from the map, and it's able to face in that direction. You'll see two black things here. Those are Patrick's feet, actually. He's sitting on the stairs, so his feet were just sitting there. They hadn't moved. So you can see that it's things that there are actual obstacles there, so it'll try to avoid it in that.
Okay.
So if, for example, you have my feet here, it'll actually try to avoid this in that instance. If it was stationary, but since I was moving, it recognized that there wasn't actually an obstacle there, it's a moving dynamic object, so it actually won't matter too much and it'll move around.
Okay.
And you can see the little line that's kind of moving in the shortest path around which we kind of chose, and it'll face in the direction right here at the end, it'll switch, in the direction that we ended up choosing for it.
Okay. So you said that there's one problem that you faced when it's the glasses or something it doesn't detect.
Correct, yeah.
So is there any
metal,
solution for that?
There really isn't, not with LiDAR. The only way you can do it is if you merge the camera inputs with the LiDAR inputs, and then from there, basically recognize that this is not something that's not air, but there is something there. And then once you merge those two specific things, you'll know like, hey, you have to avoid that. This isn't something that's there. But you won't be able to necessarily map very accurately with just the camera. You need to have a LiDAR to know how the depth of perception of how much is actually there.
Do you have any questions?
What is this like map of? Is this what the
That's what the video is there. Yeah. So it's like a hallway.
It says a sensor like that detects the movement around. Like, is it that one showing?
Yeah. So it basically just again, it's a hallway that we just mapped earlier, and it basically just shows how it would look. And then it's kind of like a 2D.
so is this generated by the system?
Correct. Yes. So the software takes in the LiDAR inputs, and what it does is basically creates the map.
So what is the machine learning here is mainly responsible for?
Pardon?
The machine learning thing?
Yeah.
What is it mainly responsible for on this?
A lot of the machine learning that we have is in the, again, using the object and range section that we have here. It's separate from what we have in the project, but we're basically supposed to take this and apply it to another car.
Okay.
That's basically what it was. A lot of it, this was basically very straightforward. It wasn't really to do with machine learning as much. A lot of the machine learning stuff is already pre-organized for us, basically.
Okay.
Yeah, there's also, again, other projects that have light sensors and other types of robot sensors. And even the guys over here as well. They do something very similar where they had like a course. It was definitely cool to check both of those out as well. So they kind of have something similar to us.